Good morning everyone, my name is Sunil Pant, I am a physics teacher at Sri Ram Centennial School. Today we are going to do hands-on on Newton's three laws. So the very first law is Newton's first law of motion, also known as law of inertia. So in this case, we are going to demonstrate you with two glasses and a piece of paper how does this law work. So let me tell you the statement of this law first. So this law says that if a body is at rest, it will remain at rest, and if a body is in motion, it will remain in motion until unless there is an external force applied. So what we are going to do in this case, I am going to apply a force on this piece of paper, and since the glass is at rest, it is going to remain at rest because the force is not applied on this glass. It is applied on the piece of paper. Okay, but you have to keep one thing in mind, that when the force is applied, you have to be very quick in applying the force, because there is a force of friction between this piece of paper and glass, and because of that there is a possibility of the movement of this glass. So let us try to apply the force. As you can see, the glass is at rest, piece of paper is at rest, and I am applying my force on the piece of paper, not on the glass. So glass is possessing an inertia of rest, and because I applied the external force on this piece of paper, this piece of paper will achieve an inertia of motion. Let us do it. Okay.
Start.
So as you have seen, first law works like this, and this is a hands-on to show the first law of Newton's first law of motion. Now coming to Newton's second law. So for Newton's second law, we have an equation F is equals to dp by dt, where this dp by dt is the rate of change in momentum, where p is momentum, F is force, and t is time. So basically this rate of change in momentum is equals to the force, or you can say directly proportional to the force. So if this rate of change in momentum is fast, then force applied will be more. But if this rate of change in momentum is less or slow, this force applied will be less. And this is Newton's second law of motion. So how we are going to demonstrate it? For that, now since F is equals to dp by dt, I have an egg here, a bed sheet. So when I will throw the egg with a full force towards the bed sheet, well, what will happen? When there is a collision between the bed sheet and the egg, so time will be provided for the rate of change in momentum, or for the momentum to change. A time will be provided, and because of that, force applied on the egg by the bed sheet will be less. Okay, so let us try this. So as you can see, the moment it got collided with the bed sheet went backwards, providing the time for the momentum to change, and therefore the force applied is less. So this is the front view of this demonstration, in which you can see the egg colliding with the bed sheet, and the law is Newton's second law of motion, which remains same. F is equals to dp by dt, that is change in momentum. If you provide time for the change in momentum, and if the in the collision the bed sheet goes back in the backward direction, so it provides the time for the momentum to change, and therefore the applied force will be less. Let us see once more. So as you can see, the egg is still okay, because when it got collided with the bed sheet went back, providing time for the momentum to change, and thus the force applied was less. So for Newton's third law of motion, as Newton's third law of motion states that for every action there is an equal and opposite reaction. So it means two forces applied on two different bodies, and the forces applied are in opposite direction. So first we'll try it with a balloon, and then we'll do another hands-on. So I'm going to blow air inside the balloon. As you can see, the balloon is having the air inside it, and the moment I'll release, I'll allow the gas to move out, or the air to move out, the air will move backward in this direction, applying a force in this direction, and an equal and opposite force will be applied in the opposite direction, and therefore the motion of the balloon will be in the forward direction. So let us see that. So this is Newton's third law of motion. Air was coming out in this direction, there was a action applied, reaction applied, and then reaction happens in the forward direction. Now for one more hands-on, we have a cane, a soda cane, and we have done 4 holes at the bottom of the cane. As you can see here, 4 holes are done, and these holes are done diagonally in a diagonal direction so that the cane can rotate. And now we are going to fill it with water, and there's a bucket full of water, and now we are going to fill it with water. So using this thread, I'll allow the cane to come out of the water. Now the cane is full of water, and as the water comes out, it applies the backward force on the cane, and since the holes are done diagonally, it allows the cane to rotate. So it becomes like a sprinkler. So this is another demonstration of Newton's third law. In this case, what we have seen is that water coming out in this direction applies a backward force on the cane in the opposite direction, and that is why the cane starts rotating. So these are the 3 hands-on experiments on Newton's laws of motion. Thank you.